Newly released image of 3I Atlas confirms it's not a comet, stunning researchers worldwide.
The arrival of the interstellar object, 3I Atlas, has shaken the entire astronomy community. Every movement of it has been carefully recorded, yet the closer it gets, the stranger it becomes. Its path is too perfect, its blue light too unusual, and its sudden changes in speed have made Harvard physicist Avi Loeb deeply suspicious. He warns that this may not be a natural comet. His hypothesis suggests that 3I Atlas could be a form of technology built with purpose, possibly from another civilization. 3I Atlas is not merely a chunk of cosmic ice and rock. It appears to be reacting to our every observation. Each time our telescopes are pointed in its direction, its trajectory and activity shift in inexplicable ways. For months, the world had watched 3I Atlas with curiosity instead of fear. Telescopes across continents tracked its every move, and people began to treat it like another cosmic visitor passing through the neighborhood. The headlines stopped sounding urgent, the news turned quiet, and scientists started talking about data, not danger. It was as if humanity had decided that 3I Atlas was harmless. But just as the calm began to settle, one voice cut through the silence. Avi Loeb, a physicist from Harvard, known for challenging what others take for granted, warned that something didn't add up. He looked at the newest data and saw patterns that no natural comet should have. The orbit was too exact, the reflection too steady, and the energy readings too clean. In his eyes, this was not the randomness of nature, but the fingerprint of design. When NASA officially classified 3I Atlas as an interstellar comet, most of the scientific community nodded in agreement. Loeb did not. He think that this could be a piece of technology built by an intelligent civilization. The statement spread like wildfire. Some dismissed it as imagination, others called it bravery, but everyone listened. Because Loeb was not a conspiracy theorist. He was one of the most respected astrophysicists on Earth, and he was willing to risk his reputation to ask what others were afraid to ask.
Around the object from scattering sunlight, and the question is, what is producing that light?
He pointed to the strange 6-minute brightness spike that had been captured by observatories around the globe. In that short window, 3I Atlas brightened by 1.4 magnitudes, too sudden, too precise, too synchronized to be random. Natural comets flare in chaos, not in perfect rhythm. To Loeb, this meant control, and control meant intention. He also noticed that its color was unusually blue, a tone that suggested extreme heat or a complex chemical reaction beyond typical cometary activity. If it was reacting to the sun, it was doing so in a way that looked deliberate. Soon, debates broke out across universities and online forums. If someone was still listening, they would hear nothing now, only the faint hum of a world that had given up trying to speak. For half a century, that silence defined us, until the night of July 1st, 2025. He reminded everyone that ignoring small probabilities had cost science many discoveries before. What if 3I Atlas was more than a comet? What if it was evidence that someone, somewhere, had already reached us? For the first time since its discovery, 3I Atlas stopped being just a point of light in the sky. The first clue that something was wrong with 3I Atlas came from its material itself. When NASA released the initial spectral data, scientists expected to see the same chemical signature found in most comets: ice, dust, and a mix of metals like iron and nickel. But instead, they saw something strange. The readings showed an abnormally high amount of nickel and almost no iron at all. That detail might sound small, but in astrophysics, it changes everything. Nickel and iron are born together inside stars under the same heat and pressure. They are like twins. always found side by side in natural cosmic objects. To separate them requires a process of refinement, something that usually happens in industrial furnaces, not in the vacuum of space. Loeb pointed out that if 3I Atlas truly lacked iron, it would mean that its metal had been purified somewhere, or somehow. And that word purified raised a question that no telescope could easily answer. At the same time, another odd pattern appeared in its gas composition. Normally, comets are made mostly of frozen water. But this one had a carbon dioxide to water ratio of 8:1. That is 6 standard deviations higher than any comet ever studied. To put it simply, the difference is so large that it cannot be explained by random chance. Its water content made up only 4% of its total mass, far lower than what any natural model predicts. If this were truly a comet, it would be the driest one ever recorded. Even its reflection looked wrong. Instead of the soft light of dusty ice, 3I Atlas reflected light as if it were coated in metal. Polarization tests showed an unusually strong negative value, a property seen in smooth metallic surfaces but not in natural space rocks. The light was almost mirror-like, clean and consistent, without the rough scattering of dust. To Loeb, that pattern matched something closer to aerospace alloy than cosmic debris. He described it as engineered material, something that might have been built rather than formed. When compared to thousands of comets on record, 3I Atlas stood completely alone. No one could find another object with the same chemical or optical fingerprint. The deeper researchers looked, the less sense it made as a natural body. Was it possible that 3I Atlas carried the remains of an ancient probe, its surface weathered by billions of years in interstellar space? Or were we seeing the outer shell of something still working, a kind of technology designed to survive across star systems? Loeb refused to claim proof, but he urged scientists not to look away. He said that ignoring what does not fit the model is more dangerous than being wrong, because in science, every anomaly could be the first sign of something new. And if the material of 3I Atlas was not born in nature, then what kind of force could have built it? That question would lead to the next mystery, the light that burned hotter than the sun. When 3I Atlas came closer to the sun, something extraordinary happened. Its soft emerald glow suddenly turned into a piercing blue light that spread across telescopes worldwide. For a few short hours, astronomers were watching a comet that burned brighter and hotter than anything they had seen before. The blue color was not just beautiful, it was unnatural. Normally, comets glow white or yellow, the result of sunlight reflecting off ice and dust. But blue light means energy, extreme heat, and radiation levels higher than the surface of the sun itself. In scientific terms, the color suggested a temperature above 5,800 Kelvin, a number that should have vaporized any natural material instantly. Yet 3I Atlas stayed intact. The James Webb Space Telescope captured something even stranger. As the blue glow intensified, its infrared readings dropped by about 60 Kelvin. That means the object was cooling in one wavelength while heating in another. To Loeb, that behavior looked like a machine that was absorbing energy and converting it into something else. It was as if the object were not reacting to the sun, but using it. No known chemical reaction in space can cause a body to heat and cool in 2 different directions at once. Some researchers compared the pattern to an energy system balancing itself, like a reactor managing temperature. Others tried to explain it as an outgassing effect, where frozen gases explode when warmed, but there was one problem. The light from 3I Atlas did not fade like a natural outburst. Instead, it pulsed. Every few minutes, the brightness rose and fell in a rhythm that repeated again and again. It was a pattern too regular to be random. Some amateur astronomers who recorded the event described it as a heartbeat, slow, strong, and deliberate. In Loeb's eyes, that was a clear sign of control. He suggested that these pulses could come from an internal energy source, something similar to an ion drive or an artificial propulsion system. The timing between pulses matched the energy range of low-frequency plasma thrusters used in spacecraft design. If true, that would mean 3I Atlas was not only maintaining its own heat, but also managing its motion. The possibility was hard to accept, yet the data left no easy answers. No comet had ever shown a light curve so consistent or so precisely timed. Each surge of brightness carried the same intensity, the same duration, and the same fade. It behaved like a coded signal, as though the object was following instructions written long ago. When Loeb was asked about the pattern, he said only, "This is not noise. It's something organized." For him, this wasn't evidence of chaos in nature. It was evidence of order in the unknown. The blue light became a signature, what he called a mark of power. If that interpretation is correct, it means 3I Atlas was not just shining, it was communicating through its light. But if the light was truly controlled, who or what was guiding its path? Look at the path of 3I Atlas and the light surrounding this object, and you will be overwhelmed. After the blue glow faded, astronomers shifted their focus from the light to its path. And that's where the real mystery began. Everyone expected the object to drift freely, just like any other comet thrown into the solar system by chance. But the more data they collected, the less it behaved like a random traveler. Its orbit was too precise, too flat, too perfectly aligned with the plane where all major planets circle the Sun. The odds of that happening by accident were about 1 in 500. And that number alone was enough to make scientists uneasy. As telescopes tracked its course, they noticed something else. 3I Atlas was passing by Venus, Mars, and Jupiter in near-perfect intervals, each encounter spaced almost evenly apart. The pattern looked like a schedule, not a coincidence. Harvard's Avi Loeb called it non-random navigation, suggesting that its movement might be guided or pre-programmed. Each time the object neared a planet, its brightness rose in a predictable rhythm, then returned to normal as it moved away. If this were caused by natural gas jets, 3I Atlas would have lost billions of tons of material, yet there was no visible dust, no tail, and no cloud of debris left behind. Its surface remained sharp and stable, its motion smooth and steady, almost like something was adjusting its course in real time. For Loeb, it looked less like a drifting rock and more like a probe following commands. Some scientists tried to explain the turns as gravitational assists, but the timing didn't fit the math. Each curve came too soon or too late for a natural interaction with gravity. It was as if the object knew when to turn before the planets could even pull it. Loeb compared it to a spacecraft using planned flybys, taking advantage of gravity like stepping stones across the solar system. Then came the strangest part. For several weeks, 3I Atlas disappeared behind the Sun, completely hidden from Earth. All major observatories paused their tracking to protect their sensors from the solar glare, leaving humanity blind. When the object reappeared, its orientation had shifted slightly, just enough to suggest a new trajectory. To Loeb, it was clear. Whatever 3I Atlas was, it had used that blind spot to change its course. In spaceflight, such a maneuver is known as an Oberth effect, where a craft uses a star's gravity to gain speed. That kind of move requires timing, control, and intention, none of which belong to a natural comet. Its path now looked less like an accident of nature and more like a mission plan written in starlight. But if 3I Atlas was following a plan, then one question still haunts scientists today. What destination could be so important that it was worth crossing the galaxy to reach? When 3I Atlas reappeared from behind the sun, everyone expected NASA and the world's observatories to flood the internet with new data, but what came instead was silence. The usual public updates stopped. Images that had been freely available on NASA's data servers began disappearing without explanation. Researchers who tried to access telescope logs found maintenance mode notices where open files used to be. At first, it seemed like a technical glitch, something routine that would be resolved in a few hours. But as days turned into weeks, the quiet became suspicious. The silence felt intentional, as if the information itself had suddenly become too sensitive to share. The last confirmed readings came from the Mars Reconnaissance Orbiter and the Solar and Heliospheric Observatory. Both recorded 3I Atlas glowing intensely as it neared the Sun, and then nothing. The next scheduled batch of data never appeared. When journalists pressed NASA for answers, the agency released a short statement: "Data integrity under review." No further clarification followed. For most people, that phrase meant little, but for Avi Loeb, it meant everything. He told The Hill that the delay might not be because NASA knew too little, but because they knew too much. He reminded the public that government agencies often act slowly when discoveries carry massive implications. And if 3I Atlas was behaving like controlled technology, the implications would be beyond anything humanity had faced before. While official sources stayed quiet, independent observatories and amateur astronomers kept watching. Across Europe and South America, small private radio telescopes reported the same strange event, a faint 12-second signal that repeated twice before vanishing. The frequency it used was 1,420 MHz, the natural emission line of hydrogen, the most common element in the universe. For decades, scientists have called it the cosmic channel, believing any intelligent civilization would use it to send messages because it is universal and easily recognizable. That made the signal too coincidental to ignore. Even more unsettling, 12 seconds after the pulse ended, sensors in several countries recorded a tiny but measurable change in Earth's ionosphere, about 0.02 Hz. It was a whisper-small shift, yet perfectly aligned in time with the hydrogen pulse. To some, it suggested a direct interaction between 3I Atlas and our planet's magnetic field. NASA made no comment, but Loeb's team noted that the signal's symmetry and timing were far too clean to be random interference. It looked organized, like a process responding to external forces, or perhaps deliberately sending a response of its own. The idea spread quickly online. Some believed it was a simple energy discharge. Others thought it was a message, or maybe an echo from a system not meant to communicate, but to record. For Loeb, even that possibility was enough. Even if it's not a message, he said, it proves there's order inside it. The absence of clear answers only made the mystery worse. YouTubers, astronomers, and journalists around the world started noticing patterns in NASA's silence. Press inquiries were left unanswered, and live telescope feeds were temporarily restricted. Within a week, hashtags like #AtlasBlackout and #NASA knows began trending across social media. People demanded to know why a supposedly harmless comet required this level of secrecy. Was it fear of public panic? Or was someone trying to understand the data before releasing it to the world? Loeb criticized the hesitation directly, saying, "We respond faster to online rumors than to discoveries that could redefine our place in the cosmos." To him, silence wasn't caution, it was control. And for many observers, that blackout spoke louder than any official statement ever could. It felt like the moment when humanity stopped looking outward and started realizing something might be looking back. If the signal was real, then maybe the question was no longer about observation. Maybe 3i Atlas had already noticed us. And if that's true, the real mystery is not what it's made of, but what it wants. What if the silence we fear from NASA isn't theirs at all? As the silence continued, Avi Loeb began to look at the bigger picture. If 3i Atlas was truly behaving like technology, then it raised a question humanity had never seriously faced before. What if we weren't the only civilization building machines? He explained that the Milky Way is billions of years older than the Sun, which means other intelligent species could have existed long before humans even appeared. If one of them developed space travel earlier, their probes might already be drifting across the galaxy. And perhaps 3i Atlas was one of them. To Loeb, this idea wasn't science fiction, it was probability. He argued that with over 100 billion planets in our galaxy, believing Earth is the only source of intelligence would be arrogance, not logic. He reminded everyone that humans already send robotic explorers like Voyager and New Horizons into interstellar space. So why couldn't another civilization do the same, millions of years before us? The thought was simple but powerful. If 3i Atlas was designed as a surveyor, its perfect orbit through Venus, Mars, and Jupiter might not be random. Those are worlds with atmospheres, minerals, and in Earth's case, life. It could be a network of observations, an automated system collecting data from planets that show signs of biology. What made this possibility more intriguing was a secondary reading from the James Webb Space Telescope. Near 3i Atlas, at a distance of about 75 miles, Webb detected a smaller object, colder, dimmer, and almost invisible. It emitted faint, controlled microwave pulses, repeating every few minutes like a communication loop. Scientists called it regulated emission, a behavior typical of machines that release heat or transmit information. The signal matched the 12-second hydrogen frequency first recorded from Earth, creating the theory that the two bodies were connected, one sending, one receiving. If true, it could mean 3i Atlas wasn't alone. It might be part of a larger system, still functioning, still responding. Loeb didn't claim it was hostile or friendly, he simply said it was active. And that alone changed everything, because if the object could interact, it meant it was aware, or at least programmed to respond. It no longer fit the definition of a passive visitor. It had purpose. For Loeb, that was the true shock. The realization that humanity might not be the observer in this story, but the subject of observation. If the 3i Atlas system was built to study planets, then Earth was already on its list. And that leads to a far deeper question, one that even science can't yet answer. What happens when the thing we've been watching starts watching back? By the time 3i Atlas left the inner solar system, it had already changed how scientists saw the universe and themselves. For Avi Loeb, the biggest discovery was not about the object itself, but about how humanity reacted to it. In his view, the greatest danger wasn't that the object might be artificial. It was that most people refused to even consider it. He warned that science loses its purpose when it stops asking questions that feel uncomfortable. To him, 3i Atlas was a mirror held up to our civilization, showing both our progress and our fear of the unknown. Even if it turned out to be natural, he argued, the episode exposed a weakness in the way we face mystery. We wait for certainty before we act, even when the universe is already moving around us. That hesitation could cost us the chance to recognize something extraordinary when it finally arrives. He pointed to the way agencies delayed data, the way experts dismissed questions, and the way silence replaced curiosity. That silence was not caution, it was arrogance. It came from the belief that we already know enough to judge what's possible. But history has always punished that kind of thinking. Every great discovery once started as an idea no one wanted to hear. If humanity had ignored strange signals before, it might have missed the birth of radio waves, the discovery of exoplanets, or the understanding of black holes. And so, people should see 3I Atlas as more than an astronomical event. It was a test of imagination, a question of whether we are still capable of wonder. Because if we only trust what we already know, then we stop evolving. The object's mystery, he said, might not lie in its material or its movement, but in what it revealed about us. We are still a young species trying to measure infinity with limited tools and divided opinions. We look to the sky searching for answers, but we fear the answers might look back. Loeb's message was simple. The universe doesn't owe us comfort, only truth. Whether 3I Atlas was built or born, its existence reminded us that the cosmos is still far beyond our control. It forced humanity to remember how small we truly are and how much more we have to learn. He ended one of his lectures with a line that captured the heart of the debate. Silence doesn't mean safety. Sometimes it means someone else is listening. In that moment, the question shifted from science to philosophy. What if the first message from the stars wasn't a word, but a warning? And if 3I Atlas really was sent here for a reason, the next mystery we face might not be what it is, but what it's waiting for. As 3I Atlas fades into the distance, it leaves behind more questions than answers. Its strange movements and unexplained signals remind us that humanity might not be alone in the universe. If there are other forms of intelligence out there, then every object crossing our skies could be a message, a test, or a discovery waiting to happen. It's a sign that exploring space is no longer just about curiosity. It's about understanding our place in something far greater. Because one day, when the next visitor arrives, we need to be ready to face it with open eyes and open minds.